Okay, 11.3c. There are a lot of moving parts here. So you need to go to Canvas in Module 11, and you need to open up the Google spreadsheet. That's where our data is. And then I believe you only have viewing rights for that. So for the last two problems, you're going to need to create your own spreadsheet, or maybe you can save this. I'm not sure, which will be easier for you. Okay. Also, you need, so this is what the spreadsheet looks like. It has 4 worksheets with a bunch of data in it. You also need to open the Rossmann one chance, and we're going to do least squared regression. Now, I played with several different ways to do this. The crazy thing is, spreadsheets are not very good at statistics, which is weird, right? They're just clunky, and they will do almost everything you want them to do, but it's a mess. So we are going to use this, and we're going to put our own data in. Okay, so here's our worksheet. So the instructions say, open the Rossmann app website and select least squares regression, clear the data, and type GPA space ACT. So I'm going to do this from my computer. All right. So clear, and in here I'm going to do GPA space ACT, and then push enter. Okay. And then I'm going to go to GPA and ACT, and I'm going to highlight all of the data, copy, and then paste it right there. And then if you click use, it will draw you a scatter plot. Okay, can you handle that? So GPA space ACT, and notice it has put GPA on the x-axis and ACT on the y-axis. And then we copy that data from the spreadsheet, and it shows up in 2 columns, and it builds this. All right. So problem 1 on your worksheet says, using the show movable line tool, estimate the equation for the regression line. So if I click this button here, I can move it up and down using the center, and then I can change the slope. And as I do that, I get this line, the equation of the line. And if you want, you could do show the squared residuals. And so the sum of the squares right now is 861. So I basically play with this and try to make that number smaller. 836. $835. That might be as small as I get. Okay, estimate. So I'm thinking this is like a, I don't know, 0.4. And then I can show the correlation coefficient. Oh, 0.7, I was way off. And I can show the regression line. So that's the regression line I got, and this is the actual regression line. I didn't do too bad. I was just off by a little bit. Okay. So, what does this number mean in this case? What does the y-intercept mean in this problem? If you have a GPA of 0, your predicted ACT score is 9. Does that make sense in this context? Yeah, that makes total sense. It might not be accurate, but it makes sense. But if you have like height and weight, somebody who is 0 inches tall weighs 50 pounds, that wouldn't make any sense. There are no 0 inch tall people, and if you were 0 inches tall, you wouldn't have any weight. Okay. What is the R squared value? So that's the R squared value, 0.495. And then number 7 says, explain what the R squared value means in this context. So it would be 49.5% of the ACT score can be explained by the linear regression of the GPA. So that's similar to what we did in the last worksheet. Okay. Next, number 8, if a new student has a GPA of 2.1, what is their predicted ACT score? So you're just going to plug 2.1 in here. Same for number 9, 3.9. And number 30 says if a student has an ACT score of 30, what is their predicted GPA? So I can't plug 30 in here and get an accurate answer. What I need to do is flip the explanatory in the response, and that's going to change my regression equation. And now I plug the ACT score into here. Okay, does that make sense? Next up, go to this page. So you can start this in class, and this is one of those days where I'm going to let you pull out your phones. Okay? You are not allowed to interview anybody in this class. Okay? So you need to find a male-female couple, whether they're dating, fighting, married, whatever. However you want to do it. I don't care if they're in elementary school or middle school or they're 95, whatever. So you need to ask 30 male-female couples how tall each of them are. And just for simplicity's sake, we're going to graph male on the x-axis, female on the y-axis. Okay. Once you have all of those people written down, you need to open up a spreadsheet and add a page and enter all of your paired data. So male will go on the x-axis and female will go on the y-axis. And then you'll come here and clear this, and you will type male space female, enter, and then you will copy all of your data there, and that's how you're going to get the information you need. All right, and lastly, on the last page, you are going to ask 30 people who have ever owned a car. And you're going to ask them how old they were, when they got their first car, and how much that car was worth. Okay? Any questions? All right. Get to work.